Hi, everybody. Well, we're doing section 2.3 right now. And I guess what I want to say first is that math is full of patterns. And not just that, but we analyze patterns. We notice patterns and we see things, and sometimes we can make rules, formulas, who knows what out of them. And that's kind of going to happen a little bit today. So with no further ado, I hope that was mysterious sounding enough. I'm going to jump right in to our 2.3 power and sum rules, sum with a SUMO, you'll see in a second. Okay, here we go. So I'm going to share my I'm not going to share my screen. I'm going to switch cameras. So this here is that's my hand right now. This is just a piece of paper and I'm writing on it. So it's the wrong thing. That was it. So 2.3 product and sum rules, case one. Y equals 1. It's a very nice function. So y prime is equal to the limit as h goes to 0. I'm going straight to the definition now of f of x plus h minus f of x over h. And in this case, that's equal to the limit as h goes to 0 of, well, f of x plus h is just 1 because it's a constant function. So no matter what the input is, the output is always just 1. So it's 1 minus f of x, which is also 1, over h. And this is equal to the limit as h goes to 0 of 0 over h. But 0 over h is just 0. So this is equal to the limit as h goes to 0 of 0. Well, h goes to 0, 0. There is no h now. There's nothing to do anything. So I have no problem substituting and just putting the h in there. There is no h. So the answer is just that number right there, which is 0. Wow. So y prime equals 0. Now let's look at the second case, case 2. Case 2, y equals x. All right, fair enough. So y prime is equal to the limit, again, by definition, as h goes to 0 of f of x plus h minus f of x, this is the definition, over h. And this is equal to the limit as h goes to 0 of, well, f of x plus h, well, y is just equal to x. So whatever the input, the output is the same as the input. So this is just x plus h minus f of x is just x over h. And that is equal to the limit as h goes to 0 of h over h. But h over h just reduces to 1. So this is the limit as h goes to 0 of 1. Well, again, there's no h in there, so there's nothing to do. I'm just going to remove the limit. The limit is done. There's no limit. I mean, we're done here, and the answer is 1. The derivative is 1. All right, so y prime equals 1. Now to the case 3. Y equals x squared. Well, y prime is equal to the limit as h goes to 0 of f of x plus h, which is x plus h squared, minus f of x, which is x squared, over h. And this is equal to, again, the limit as h goes to 0 of x squared plus 2xh plus h squared minus x squared. Don't forget that minus guy right there, over h. Now I'm going to, first of all, we're going to cancel out these x squares. I have a plus x squared and minus x squared. They just go bye-bye. Second thing I'm going to do is I'm going to notice in the remaining surviving terms on top, you have it 2xh and h squared. They both have an h in them. So I'm going to factor out that h. I'm going to clean this thing up a little bit, and I'm going to make it look like this. This is equal to the limit as h goes to 0 of h times 2x plus h over h. And notice that I could just cancel out these two h's right there. And now I'm going to continue. This is equal to the limit as h goes to 0 of 2x plus h. There's really no more fraction. And now I've gotten it to a point. See, I could just plug in h equals 0. See, I couldn't just plug in h equals 0 before this point, because that would always give me a 0 on the bottom of the fraction. But now we got it down where I could, do that right now. So finally, the limit is just 2x. By the way, notice that I kept on writing limit. It wasn't because all this time I didn't actually do any limits. I didn't do any. All I did was algebraic manipulation, just factoring and expanding a binomial and reducing and so on and so forth. Either way, y prime is equal to 2x. So let's just look at the results here. I'm going to put all the results. Let's just look at all the results here. Put them in nice little boxes here. So these are my final results. Okay, I want to do one more case. This is case 3. Case 4, sorry. Case 4. Now will be y equals x to the third. So for y equals x to the third, let me just move this. This is my actual hand. I am a lot. When I'm in this mode, you don't really see my face like I normally like to show it. I have to show my face just so you should know, just so you'll know that I'm an actual real human being, and I really exist and so forth. But I can't really get in that mode. So, but this is my hand. It's me. Okay, I'm gonna wiggle my pinky. See, I just wiggle my pinky. Okay. Okay, that seems to work. Y prime is equal to the limit as h goes to 0 of x plus h to the third power, because that is f of x plus h, minus x to the third power over h. Now this is equal to the limit as h goes to 0 of x cubed plus 3x squared h plus 3x h squared plus h cubed. That's all this first part. And then minus that x cubed over there. Of course, all over h. But notice that I conveniently have a plus x cubed and a minus x cubed. Now I'm going to do something similar to what I did up above in the previous case. I'm going to factor out an h on top because I have everything. I'm able to do that. And this is now going to be equal to limit as h goes to 0 of h times 3x squared plus 3xh plus h squared over h. Now these h's cancel. Simple, straightforward algebra. And this now gives you the limit as h goes to 0 of 3x squared plus 3xh plus h squared. But notice at this point, I have no problem because I don't have any. See, I couldn't just plug in a 0 up here or there because I would get a 0 on the bottom of the fraction. Here, I don't have that problem. So the final answer is just 3x squared. So again, if y equals x cubed, y prime is equal to 3x squared. So what I want to do now is just sort of tally up the results. Let's just tally up the results here. But here we see. So for when y equals 1, y prime was 0. If y equals x, y prime is 1. If y is x squared. Now I'm going to write this now. I'm going to write down all the results on one table. So here is, just put one table here. There we go. So here's f of x. And here is f prime of x. So we had 1, x, x squared, and x cubed. And f of x was 0, 1, 2x, and 3x squared. Now, I'm going to write this a little differently also. That's technically x to the first power. Okay. And this is technically, 1 is technically x to the 0 power. So notice that I have a 0 exponent, a 0 constant. A 1 exponent, I have a 1, a 2 exponent, and a 2, a 3 exponent, and a 3. Notice that here I have an x to the third power. The 3 dropped down to a 2. X to the second power, the 2 dropped down to a 1. X to the first power, well, actually, the 1 actually dropped down to a 0. See what I'm saying? And here, once I have the 0, it doesn't matter. The x doesn't matter. So, if you're noticing, let's say, for example, I had x to the fourth. It would seem, just based on the pattern, based on the pattern that seems to be emerging here, it would seem as though I'm going to take that 4 and stick it out in front, and then drop the exponent by 1. That would be my answer. And if you would think that that's the answer, well, you are actually correct. So now we have our first rule. This is actually a rule. It's called the power rule of derivatives. And the power rule so if y equals x to the nth power, y prime is equal to n times x to the n minus 1 power. And that's the power rule. And that is that. And so therefore, if I would have x to the 5th, so here n is equal to 5. So y prime is going to be n, which is 5, times x to the 5 minus 1, which is 4. So let's look at another example. Suppose you had y equals x to the 1 1/2 power. What is y prime? Well, y prime is going to be 1/2 times x to the 1/2 minus 1. Now, 1/2 minus 1 is 1/2 times 1/2 minus 2/2, which is equal to 1/2 times x to the negative 1/2. And that's the answer. That's the answer. That was the original function. That's the derivative. So you see, this works. Numbers work. It works with negative numbers. If y equals x to the negative 7, y prime is going to be equal to negative 7 times x to the negative 8. Not 6, but 8, because negative 7 minus 1 is negative 8. And this is a awesome, incredible rule. The power rule is no problem. Okay, now I want to look at another fascinating rule. Let's say now that y is Let's say now that y is equal to k, some constant. K is just any random constant times f of x. So k is a random constant. F of x is a random function, but it's a function which can be differentiated. Well, let's look at y prime. Y prime is going to be equal to the limit as h goes to 0 of k, f of x plus h minus k f of x over h. Now notice I'm going to make this even a little more clear. This is equal to the limit as h goes to 0 of k times f of x plus h minus f of x over h. Now notice now k is just a constant. 3, like 3, 4, 5, negative 7. What's this? K is just a constant, so I could pull a constant out of a limit. We've learned that. So y prime is equal to k times the limit as h goes to 0 of f of x plus h minus f of x over h. And this is just equal to, well, that's k, that's the constant. The rest of this part over here, that's just equal to f prime. So what we see here is that y prime, so if y is equal to k f of x, then y prime is just equal to k f prime of x. And that's very helpful for y. Let's say, for example, I gave you y is equal to, just make an example here. Suppose I had y is equal to 7x to the 5th. So, well, y prime is just going to be 7 times 5x to the 4th, because it's just that constant k, 7, times the derivative times f prime. F prime, is 5x to the 4th, and this just becomes 35x to the 4th. Very simple. It all works out very simply, very, very nicely. Let's do another example. Suppose y is equal to negative 5 times x to the 1/3 power. Well, this tells us that y prime is equal to negative 5 times 1/3 times x to the 1/3 minus 1, which is equal to, just cleaning this up a little bit, negative 5/3 times x to the negative 2/3. That's our answer. Now I want to show you another very super duper important rule, and that is a rule that's called the sum rule. Now I'm not going to prove it, but I'm going to state it. If you have all right, so I'm going to have to change to different. I'm going to have to share my screen, and I'm going to put that right there. Okay, now you should all see this. So here's the constant multiple rule that we just did. D dx of kf, the derivative of kf is k times f prime. And here's a super important rule, the sum or difference rule. which is that this is basically saying the derivative of the sum of two functions is equal to the sum of the derivatives of those two functions. Similarly, if it's a difference, the derivative of the difference is equal to the difference of the derivatives. And that is an awesome, awesome rule. Now, the power rule, of course, is just restating what we said already. But here now it looks more fancy. The derivative of x to the nth power is n times x to the n minus 1. The derivative of a constant is just 0, because it's just k times x to the 0. And the derivative of x is 1, because x is just x to the first power. This is all what I had shown you just a few minutes ago. So let's go back now to the other modality. How do I do that? To stop the share, and I have to go like this. Okay. Now I'm going to do an example. Suppose we have y is equal to 3x to the 5th minus 2x to the 3rd plus 5x minus 743,892. Well, y prime, we're going to use now. See, the sum rule and the difference rule means that I could just tackle each of these things individually and just write down the results. So this is going to be, well, the 5 comes out to the front, multiplies, in this case, multiplies a 3. So I get 15x to the 4th. Here, the 3 comes out to the front, multiplies the negative 2, so I get minus 6x squared. In this case, it's just going to be 5. And this whole thing is just going to disappear. So that's my answer right there. Very nice. Very nice, very simple, very short, very sweet, and very lovely. Let's do another example just to make it excruciatingly horrible. Suppose we have y is equal to 4x to the negative 7 halves. So 4x to the negative 7 halves plus 2x to the negative 5 plus x to the 1/17. Okay, well, y prime is going to be the negative 7 over 2 times 4. That's just going to be, well, negative 14. X to the negative 9 over 2. How do I get 9 over 2? Well, negative 7 over 2 minus 1 is negative 9 over 2. Now here, I'm going to multiply the negative 5 times the 2. So it's going to be minus 10 times x to the negative 6. Not negative 4, but negative 6, because these are negatives, they get bigger. And finally, this one over here is going to be 1/17 x to the negative 16/17. I think it's 16/17. 16/17. That is the truth. Now I want to go back to that screen. There's another very nice, another very nice rule, which again I'm going to show you but not prove. So let me go back here and back to my share. There you go. And now we have two rules here. One is called the exponential rules and the logarithmic. So now you presumably you learned the number e. E is an irrational number. It's approximately 2.7, and the derivative of e to the x power is e to the x power, which is very easy. Suppose you have a different base, not e, but just some number. A could be 5, 10, 7, whatever. So the derivative of a to the x power is the ln a times a to the x power. And I want to show you this last rule, and then I'm going to give you some examples. you remember logarithms. Ln of x means the natural logarithm of x. That means the log of x base e. If I take the derivative of ln x, I just get 1 over x. And that's pretty cool. The derivative of ln x is just 1 over x. Now let's go back to the show you some examples here. So I'm gonna move this here and come back to my IPvo. And here we go, and we're ready to start. So let's get some nice examples. And of course, I could roll a whole bunch of examples into one. If y is equal to y equals e to the x power plus three ln x plus 7 to the x power plus x squared. Why not? What is y prime? Well, we could just do each of these one by one. The derivative of e to the x is just e to the x. That one's nice and easy. The derivative of ln x is 1 over x. So this becomes 3 times 1 over x, which is just 3 over x. This guy over here becomes ln 7 times 7 to the x. Now I'm gonna put parentheses here. I just want you to realize it's not the ln of 7 times 7 to the x. It's the ln of 7, which is a constant number you could get in your calculator, times 7 to the x power. And the ln, the derivative of x squared is 2x. And there you go. Let's do, this is something I just want to show you here. Another example. Y is equal to the square root of x. Y is equal to the square root of x plus 1 over x. Now, the derivative of ln x is 1 over x, but what's the derivative of 1 over x? Well, to do this problem, I really need to rewrite this in exponent form. Well, the easiest way to do this problem is to rewrite it in exponent form. And square root of x is x to the 1/2 power. And 1 over x is x to the -1. And once I do that, then I could just say that y prime is equal to 1/2 x to the -1/2 minus x to the -2. Since the problem started without exponents, I'm going to convert it back to exponent radical. See what I'm saying? So y prime is equal to 1 over 2 rad x minus 1 over x squared. This is another way. This is just a simplified way or a different way of writing this. This is writing it with exponents. This is writing it without exponents. Okay, let's go. And I'm going to call this example. Oops, we're still in the air. Let's do another example, and that will be y equals 3 square root of t minus 4 over t to the 4th power plus 5 e to the t. Well, first thing I'm going to do is, and I want to, let's just to be good here. First, what I want to do is rewrite these into exponent form. So y, just plain y, is equal to 3 times t to the 1/2 minus 4 times t to the -4th power. And this I don't have to do anything to. It's just plus 5 e to the t. We're fine. Now y prime is going to be 3 halves, because the half exponent multiplies the coefficient 3. times t to the 1/2 minus 1, which we already showed is equal to negative 1/2. And here the negative 4 for the multiplies that negative 4, so I have plus 16 t to the negative 5th power, because negative 4 minus 1 is negative 5. And this is beauty. This is just stays 5 e to the t. It couldn't be easier. And there you go. Now we're going to look at a function. Now we're going to look at a different problem. Let's say we have a function g of t, and g of t is equal to 10 minus t squared. And what I want to do is I want to find not just the derivative, but I want to find the equation of the tangent line to the point to the point y I'm sorry, t equals 2. So first of all, I want to, you don't have to draw a picture, but I do want to draw a picture. And this is really an upside down parabola. Now, this point over here is 10. And we want to know when t equals 2. So first of all, t equals 2, where is it? Is that above the axis or below the axis? Well, this number here would really just be the square root of 10. Because 10 minus the square root of 10 squared is 0. So this would be, square root of 10 is like 3 point something. Means 2 is like over there somewhere. So we're looking at this point right there. So this is the point where t equals 2. So the tangent is going to look something like that. Let's see. And I want to find the equation of this. Now, this is a hard, by the way, my drawing is horrible, and sorry about that. My tangent wound up touching it twice, but there's nothing. Don't go just by my horrible drawing. So, but what I do want to do is I want to find the coordinates of this point. Now, I know the t value is 2. I need to find the y value. Well, that's fair. That's simple enough. Because all I have to do is just plug in, just plug t into the function. So g of 2 is equal to 10 minus 2 squared, which is equal to, I guess, 10 minus 4, which equals 6. So this point here is the point 2 comma 6. That's that point right there. And now we want to find, well, there's a famous formula, the point slope formula. All I need is the slope of this line. But hey, calculus to the rescue. I'm going to take a derivative to get the slope. G prime of t is equal to negative 2t, because the derivative of 10 is just 0. The derivative of t squared is 2t. Got to bring down the negative. Now, negative 2t. And what is the slope when t equals 2? Just plug in 2. So g prime of 2 is equal to negative 2 times 2, which is equal to negative 4. So basically, this boils down to an algebra problem. Now, I want to find the equation of a line that goes through the point 2 comma 6, and it has a slope equal to negative 4. And that's very straightforward. Y minus 6 equals negative 4 times x minus 2. And we're done. Now, I just asked you to find the equation of a tangent. And that's the equation of a tangent, and that's it, we're done. Sometimes they may ask you to express the equation of the tangent in slope-intercept form. And if they do, all you got to do is solve for y in that form. So I'm going to add 6 to each side. Y equals negative 4 x minus 2 plus 6. Distribute the negative 4. Y equals negative 4x plus 8 plus 6. and y equals negative 4x plus 14, and that's the answer. So what am I saying here? This is really important. Because students always ask me, how do I have to write the answer? How do I write the answer? Well, it depends on the question. If I just say, give me the equation of the tangent, then any way you give me the equation is, technically is correct. If I say, give me the equation in, slope-intercept form, then you have to do it this way because this is slope-intercept form. So it really depends. I want to say something that my daughter's AP calculus teacher told them. If you write the answer without simplifying, assuming it doesn't tell you to simplify, if you write the answer without simplifying, they'll give you full credit. If you simplify it and you make a mistake in the simplification, meaning you got the right answer with the calculus, but then when you simplified it, you made a mistake, in that part. Well, if that happens, then you're going to lose points. So, it's up to you. It's up to you. If I don't ask for a specific form, you can leave it that way. Take it that way, whatever you like. If I ask you for a specific form, you have to give it in that form. If I ask it for a decimal, you have to give me a decimal. If I ask for a fraction, you have to give me a fraction. If I don't say which one, either one is fine. We're going to see. Sometimes it's going to pay. Sometimes even if I don't ask you to simplify it, it's going to make things easier if you do simplify, especially in cases where we have to do what's called a second derivative or a third derivative, but we'll get to that. Anyway, I have one last problem I want to do today, and I'm going to need to just show it to you. So let me switch, just go to camera, and let me share my screen. And let me just scroll down to the problem. Oops. Here we go. Okay. In a memory experiment, let's see here. In a memory, let me just actually want to just go there. This is example 9 in the book. In a memory experiment, a researcher asked the subject to memorize as many words from a list as possible in 10 seconds. Recall is tested, then the subject is given 10 more seconds to study, and so on. Suppose the number of words remembered after t seconds of studying could be modeled by Wt equals 4 times t to the 2/5 power. Find so find and interpret w prime of 20. Okay. So let's just do that. Wait, now I'm gonna have to go back here and now back here and okay. So we want to find well, problem told us, I'm going to write here example 9 because that's what was in the textbook, and w of t equals 4 times t to the 2/5 power. So w prime of t is going to be 2/5 times 4, which is 8/5, t to the 2/5 minus 1 power, and that's 8/5 times t to the negative 3/5 power, which is which now if I want to find w prime of 20, w prime of 20 is equal to 8/5 times 20 to the negative 3/5 power, which is approximately 2.2652. And you can just crunch it out on a calculator. And what does this, oops, where are we here? What does this mean? So this means, let's explain right here, that since W is measured in words and T is in seconds, W prime has units, words per second. That's the units for W prime. And W prime of 20 is approximately 2.2652. And that means that after 20 seconds of studying, the subject is learning about 0.27 more words for each additional second of studying. And that's what this teaches us. Well, that's the end of this. This actually, believe it or not, this is all part one. Part two is going to be of this section. I'm going to make a second video, whole second video on just some business applications of these concepts. Anyway, it's been wonderful and fabulous, and it's been a joy and a delight having you all in the do some calculus with me, and we'll see you guys next time. Bye.